Now we are gonna look one more container orchestration tool, that is our Docker Swarm. So it's great having complete control over your cluster, but sometimes the micromanagement isn't necessary. In fact, if you have a number of applications with no complex requirements, you can take full advantage of the Docker promise of being able to run anywhere. There is no reason you should not be able to throw containers at a cluster and let the cluster decide where to run them. So, a seamless Docker cluster is possible with a Docker Swarm. So, Swarm could be useful for a research lab if the lab was able to split up a computationally intensive problem into bit-sized chunks. So this would allow them to very easily run their problem on a cluster of machines. Now let's look into our first problem statement here. So we have a number of hosts with Docker installed, and we want to be able to start containers without needing to micromanage where they will run. So solution for this is we are gonna use Docker Swarm to treat a cluster of hosts as a single Docker daemon and run Docker commands as normal. So normally a Docker Swarm consists of three parts. That is, a Docker Swarm consists of three parts: agent, uh, discovery service, and a master. Agent, discovery service, and master. So figure shows how these three parts would interact with each other on a Docker Swarm with three nodes. Here we have taken the three nodes hosts with the agents installed on them. The agents are programs running on each host you want to be part of your culture, your cluster. So they report connection information to the discovery service and turn the host into a node in the Docker Swarm. So each host with an agent. You see that each host, this is our Swarm master host, and these are all our agents. So each host with an agent needs to have Docker daemon exposed on an external port. Daemon. Docker daemon exposed on an external port. So we covered how to do this. So here and so with the master is started in Swarm master host, it will contact discovery service. Here, after this has been started, it will contact discovery service to find the list of nodes in the cluster. So three nodes: Docker node 1, Docker node 2, Docker node 3. But this master host discovery service is one which is going to find out the Docker a list of nodes which are present in the cluster. From that point on, you can run commands against the cluster by directly connecting to the master, which will forward requests to agents. So minimum requirements for Docker clients: all versions of Docker used by both agents and clients in a cluster must be at least 1.4.4. That's the version. That is absolutely fine. And you should try to keep all versions exactly the same, but the cluster should work as long as your clients are not newer than your agents. The first step in setting up any Swarm cluster is to decide on the discovery service. The discovery service is very important. So the main step in setting up any swarm cluster is to decide on the discovery service you want to use. There are a few options for this, ranging from a list of IP addresses in a file to Zookeeper. So Zookeeper, if you remember, we have used this in Helios. So for this, we are going to use a discovery service built into the Docker Hub that uses tokens. So here, let's look into this infographic more clearly. So this is our Swarm master host. Docker Swarm master host runs the various services that enable Swarm functionality. Then inside that Swarm's master host, we have discovery service. The discovery service keeps track of which nodes are available to the Docker Swarm. Then we have three nodes we have, out of which Docker node 1, Docker node 2, Docker node 3, and all will be connected through discovery service. And an agent runs on each node, exposing a port to allow the swarm master to control nodes containers. Then we have a Docker node. Each node is a standard host running Docker. So each node should consist of a Docker daemon, or Docker should be installed in that node. Here two hosts are running Docker containers. The third has no container. You see that this has two containers, and Docker node 2 is having one container, whereas Docker node 3 having no container at all. And coming back to the Swarm master host, inside that we have a Docker Swarm client and Swarm master. And the Docker Swarm client is a standard Docker client. It need not run on the Swarm master host as long as it has access to the master. Then we have Swarm Master. In the Swarm Master host, the Swarm Master is the engine of the Swarm, like Docker engine. This is Swarm engine, engine of the Swarm. So issuing commands to the nodes. This is going to issue commands. You can see that green color line which is going. So this is going to issue the commands to the nodes in the cluster. So this is our one cluster. This is master, and remaining all are nodes. Docker node 1, Docker node 2, Docker node 3, and Swarm master is our main engine, Swarm engine, that is going to give commands, that is going to issue commands to the nodes in this cluster, in our cluster. So let's look into some of the commands here. So we can mention a Docker pull swarm, Docker run swarm, create, and cluster ID. So when you mention Docker run swarm create, the long string after the swarm, create command. This create command here, create command is the token you are going to use to identify your cluster. So it's important to jot it down. You jot it down this for the rest of this while you are working in this project. For the rest of the this project, it's important to have that cluster ID. So the cluster ID should be noted. After you creating that, the cluster ID should be noted, or you can simply use the cluster underscore ID environment variable to fetch that. Whatever way you like, you can do that. Then, or else that's what you can use the cluster underscore ID variable to refer that cluster ID, and you can now inspect the newly created swarm using Docker run swarm, and list token is nothing but our cluster ID, and it will start. As you can see, there is not much going on at this moment. The swarm is the swarm list command returns nothing. So querying the Docker Hub, discovering discovery service directly for the hosts in the cluster returns an empty list. So next, you can start up your first agent on your current machine using following command saying IP address show. So this will give you the basically IP addresses, and from there you can give Docker run and option D detached mode, then use swarm join, and then you join those IP addresses that we have just fetched and put them in the cluster using token colon cluster ID. So that's how you can attach them. Then the first step is to identify the IP addresses, IP address that the master will use to connect to the agent via whatever method you are most comfortable with. The IP address is used when starting the agent and will be reported to the discovery service, which means that swarm list command will be updated with the new agent information, and there is no way to do anything with the node at we need a master to be running because we are going to run the master on the same mission as an agent with the standard Docker port already exposed. We need to use an arbitrary different port for the master. For that, we are going to give a command Docker run option D, option P, that's detached mode and port mapping with swarm manage one more command, and then we'll give a token and then cluster ID. So we have started up the master and run docker info against it to retrieve some details about our cluster. The two containers listed as running are. So now let's start an agent on a completely different node. For that, again, you have to give the same command docker run option D swarm join this node which is there in this 10.194.8.7 IP address and which is there at 2375. That's where this is exposed port. The agent is being exposed to the external world using this port. And then as usual, you have to give the token of the cluster. So then this node will also be attached in that cluster. So another node has been added to our cluster. Note that we are taking advantage of the ability to access the master from another machine here. So finally, let's start a cluster. Sorry. Finally, let's start a container because the cluster has been started and we have attached different nodes to that cluster, and now it's time to start a container. So to start our container, we will say Docker option H, that's a capital H, and then TCP and public IP and port mapping. And after that, run option D detached mode and image name. With this, our containers will be up and running in specifically that cluster depends on in that cluster in the nodes that which are connected in that cluster. So there are a few things to note here. The most important is that Swarm has automatically selected a mission to start the container on. This is very important. You can see which node has been selected in the container name H1 here on the code. You can see this on the code, and the count and the container count has increased correspondingly. So as you can see, swarm automatically hides any swarm related containers, though you can list them with the option A arguments to PS. So that's how a Docker swarm will be useful in creating Docker cluster and automatically running a Docker container in a certain node which is connected in that Docker in that cluster. So now the next container orchestration tool is K8s. K8s is in short for a short notation for Kubernetes. So K8s, we are going to deep dive into the K8s. We are going to look into lot of concepts, and we are going to create a cluster and Kubernetes cluster, and inside that we are going to deploy our application. So that's what we are going to do. So that's the reason I have put it as a separate part of module 6. So I will see you in part 2 of module 6, that is Kubernetes. Until then, see you. Bye bye. Keep loving me, keep subscribing, keep liking it, and keep enjoying it, and keep spreading to everybody. And see you again in part 2 of module 6, Kubernetes.